The third in our series of ACIS Web Services webinars will be more brief than the last. It focuses on the call general. If you remember from the previous webinar, geographic areas were defined by codes such as FIPS, HUC, or CWA. Most users will not readily know the FIPS code for a county in their state or the HUC code for a river basin. General provides a way for identifying this information. General is actually a family of web services calls. The general call is followed by a slash, and then either state, county, climate division, CWA for county warning area, or basin. The call also requires a qualifier, which can be a state, the coordinates of a bounding box, or an ID. Valid ID types include the FIPS ID for a county, the 8-digit HUC identifier for river basins, or abbreviations for the county warning area or climate division. The call returns information about all states, counties, climate divisions, county warning areas, or basins that meet the qualifier conditions. For example, combining the general/county call with state as a qualifier will return all counties within the selected state. We will see later that general also includes a new metadata type called GeoJSON. Details about GeoJSON objects can be found on the GeoJSON website. Essentially, what is returned by a GeoJSON metadata object are the coordinates of the polygons that define the outline of a specified geographic area. For instance, a county's outline. At the end of this webinar, we will see an example of how this type of metadata object can be used in a climate services product. If we return to the ACIS query builder at seacis.rcc-acis.org/acisbuilder.html, we can select the general call from the list of web services calls at the top. General requires us to specify an area. The area can either be state, county, climate division, county warning area, or basin. For this example, let's choose climate division. In addition to the required area, we must also enter a qualifier. Qualifiers can be a state, an ID, or a bounding box. In this example, let's choose a state, New York. When we hit submit, the server location and parameters object is listed. Params are a single name value pair. The server identifies the general call as well as the area, in this case general/climate division. The results object is also a single name value pair. The name being meta and the value being an array. If we format the array, we see that there are 10 objects corresponding to the 10 climate divisions in New York. Each object contains the climate division ID, in this case New York 01, and name. Let's try a different example. In this case, our area will be basin. We'll select a bounding box as a qualifier. Remember, the bounding box is entered as a combination of longitudes and latitudes. When we hit submit, we see the new call, in this case to general/basin, and the parameters object, which gives the bounding box as the name and as values the list of coordinates. The returned object is also a single name value pair, with meta being the name and the value being a long array of IDs and names corresponding to the different river basins within this bounding box. When we format our results, we see that the array contains a number of objects. These objects give each basin's name and 8-digit HUC code. It's also possible to choose the metadata we'd like the general call to display. Let's try a different example. In this case, we'll choose county as our area and Wyoming as our state qualifier. Notice that different metadata are available from the different general calls. If we look at the table, we can see that since we specified county as our area, the available metadata are county ID, which in this case would be a FIPS code, the name of the county, the bounding box, which is the coordinates of a box that encompass the county, a GeoJSON object, and state. Not all areas have these 5 types of metadata available. For example, state is not available for county warning areas or basins. This is because these areas can cross state boundaries. In our current example, if we choose the meta options bounding box, ID, and name, and hit submit, We now see that the server is pointed to the general/county call. Our parameters object now contains two name value pairs: state, our qualifier, which is Wyoming, and meta. These are the metadata options we would like displayed in the results object. The results object again contains a single name value pair, meta being the name, and a long array of objects specifying the counties in Wyoming. When we hit Format, we can see these more clearly, and we see that each object in the meta array contains the county's name, the coordinates of a box, which encompass the county, and its 5-digit FIPS ID. Instead of county, we'd like to look at this data by basin and use the same example and hit Submit, and we see several things change. The first is our call is now general/basin, and our results object, when formatted, shows a rather lengthy list of basins within Wyoming. Each basin is identified by its name, the bounding box which encompasses it, and an ID. In this case, the ID is the 8-digit HUC ID. Remember, the query builder is just a teaching and development tool. We can also make the same web services call from the command line using curl. Here we can just simply cut and paste the params object from the query builder, and in the case of general, also add the proper server from the query builder. Hitting return displays the results object. The call can also be made from a browser by pointing to the proper server and then specifying the parameters. Let's do one final example using GeoJSON as the meta option. In this case, we'll choose climate division as our area. Specify our state as Kansas. We exclude any metadata options first. Hit Submit. Format. We'll see that Kansas has 9 climate divisions. Now suppose we'd like the GeoJSON object corresponding to 2 of these climate divisions. For our metadata options, we'll choose GeoJSON and also ID. Hit Submit. See the server is now pointed to general/climate division. Our params object contains 2 name value pairs, the ID for the 2 Kansas climate divisions, and our metadata option. The meta array in the results object contains 1 GeoJSON object per area returned. In this example, there is 1 GeoJSON object for each climate division. Hitting Format helps a bit. The type field is explained on the GeoJSON website. The coordinates field gives an array of longitude-latitude pairs, which when connected produce polygons that define the area. In this case, Climate Division 1 in Kansas. And in the case of the second object, Climate Division 2. The ACIS web interface to ACIS provides an example of how the general call might be used in a climate product. Currently, the map interface displaying the state of West Virginia. Clicking County Warning Area displays the county warning areas in the state. This is done via a general/CWA call, filtered by state. Not only does this call generate the list of county warning areas that cover at least some part of West Virginia. Notice the Blacksburg County Warning Area only covers a small portion of southeastern West Virginia. But also, using GeoJSON as a metadata option, the coordinates that define the outline of each county warning area are returned and used to draw these areas on the map. The development of climate service products such as this will be the topic of an ACIS Web Services Developers Workshop to be held at Cornell University in Ithaca, New York on August 7th through 9th. The workshop will feature hands-on ACIS development guided by Regional Climate Center staff. Prior to the workshop, web tutorials will provide the necessary prerequisites. 3 additional video webinars will be released sometime in June and July. Since space is limited at the workshop, we ask that interested participants please register at the following website.